This conference will now be recorded.
All right. We were talking about in the last class, about indexes and maintenance and all that, right? So there is one more topic we need to talk about in this module, transaction wraparound. So what exactly it is? I try to follow this. This is something very important interview question. Most probably you might not see this in the real time happening, but it's a very serious issue in Postgres especially. So why it is so, what happens, well, everything we'll talk about. So just follow it. Right. In Postgres, we have seen that MVCC, right? We have seen this is because of the MVCC, multi-version concurrency control. That's where the transaction wraparound will happen, in fact. If I work on the database, it will keep increasing the transaction ID for each table. If it increases beyond, like a transaction wraparound for each database is 4 billion, 4.2 billion transaction IDs in a worst case. So, can you guys see my screen, all of you? Uh, PG underscore.
Yes.
Okay, PG database. Try to follow simple concept, but very important for the interview sake. If I go on mute if someone don't have questions. So database name first. Understand this first, then I'll explain. Age of the transaction. How many where it is frozen IDs? This one from PG database. So this is going to tell you at database level what are the how many transactions you made on the database, and they got actually IDs generated. For every transaction is a transaction ID. This I was talking about during MVCC, if you guys remember. But anyway, quickly let's open it. This one. If I'm reading, this is also a transaction ID, but this won't increase the transaction ID. In fact, if I'm reading also, it is increasing the transaction ID. If I load the data, example, let's go to lab database where you have the IDs less, 337. In fact, even cloud database also very less. Let's go there. So to make that value bigger, here if I go and check these many tables we have, let's see teacher table. I want to see the size also. Which one is two? Right, class 2 is absolutely empty. Let's go and make some data there to understand this. So we have two columns. So I'm going to insert some data into it. Insert into, let's make parallel session. SU Postgres PSQL. This is very much important interview question, especially. If you don't understand, ask me the questions, not the issue. Insert into student, what was table in class 2? Class 2 values. I'm loading some data here. Example, Vijay. Right, values. It has only two columns. Okay. I'm trying to load three here. That's the problem. Fine. So I'm keep inserting this data. I'm inserting data. What happens to the transaction IDs? Okay. So let's understand that side. Then I'll conclude this topic with the notes at the end. So this is right. You see the count is growing. It was 95. So I triggered this inserts. Okay. Now the count will grow. The count is growing. If I update, example, uh, select asterisk from class 2. There are 5 records, right? So I want to update class 2, set class name to example maths. That's it. I'm not giving any condition. All got updated. So what happens in this case? this number will become 103. That has a one single transaction. In fact, if I want to update row by row, I can't do because everything is unique. It's absolutely same, right? Condition, if one condition will match everything, in fact. So quickly, let's go and load second record, third record, fourth record. So there will be hundreds of operations will go on every day on each database. This will increase the IDs, transaction IDs. That will create the very disastrous issue on the Postgres. When it happens, that's something you need to understand, right? So now the IDs would have been, gone up. You can see that it is growing. What is making this value to grow? Every individual transaction, as one batch will have one ID only, but every individual transaction will generate an ID for the transaction. Let's go and build this to just quickly to see it. I'm going to create this extension first to show in cloud database we are enabling this extension. Then I'm going to create this function. Then we'll read the table, okay, for understanding sake. So now if I want to read the table, what is the table? Class 2. So I'm going to change this to class 2. So it will generate every action what we doing is generating an like a entry here. In fact, each operation is associated with a transaction ID. If you look at these are all one ID because they are loop statement. Rest 152, 153, 154, 155, 156. You can see that they are different individual operations. In fact, so now if I go and read, so what I'm going to do, student. Here, this is the data we have, not student, right? Class 2. Here we have. So if I update one record, 14 records we have here. Now I'm going to update class 2, set class name to science maybe, where as class number 6 maybe, whatever it is. So we updated this. What does this will do? This will do the transaction with another transaction ID. If I go and read the page, we just inserted one of the record. We had up to 15 right here. If now it is 16th, you can see that there is an ID, transaction ID. So this is inserted, and there is one dead tuple created because of this. This got dead tuple. You can see that it is not active anymore. It is tagged. It is not tagged with A, right? It is a dead tuple. If I'm keep updating this thing, it is going to create the red tuples, and it is going to increase the transaction ID. See 150, 156, 159, 160 something. You see this keep increasing the values. As you are doing the operations, the IDs in the database level is growing. If you look at, it was started with how much? It was started with 100, roughly 95, I guess, in the beginning. Then 100, 102, 103, 108, now 112. You can see that. Because of these operations, my transaction IDs are growing. They are keeping active because we did not clean them. In fact, if I go and do it again, very bad statement here, I'm giving it without a condition. This is going to, okay, this is going to increase only one. Anyway, I need the more IDs to talk about. So, come on, where class? I just want to generate few more and then talk about class number 4, 3. Right, we did three transaction more. So how many? This will be 115. You can see that ID is growing. So here, whatever the transaction we are doing here, each update is creating the data tuple. At the same time, it is retaining the old transaction IDs. So try to understand the ID side here. So the IDs are keep growing. The old transaction which are got data tuple because of the update, they are also maintained. It started with 1546, it is ending with 1563. All of the IDs are active at the moment. Though some of the data is already done the job and they are still active and valid for the database count as part of the transaction. If this kind of IDs grows up to 4.2 billion in a single database, then your entire Postgres will corrupt automatically. It will corrupt. You can't do anything. That's a nightmare for any Postgres DBA. If you see transaction wraparound fatal error, kind of, it'll throw fatal error, transaction wraparound maximum reached. If that is the case, you can't start the Postgres. You have to rebuild from the backup only. It's very, very worst case. I never seen in entire my career happening that. You may not see also, but it's the interview question. This is a limitation of the product in terms of transaction IDs at the database level. Um, if you are doing too many transactions, but you're not doing the vacuum on the tables, this will grow badly because the active transaction entries will retained back, and those entries will make up the IDs. To they will contribute to 4 billion. Your database will be down. It will corrupt straight away, which is not something good. So to control this, what we have to do? At least you're getting what I'm trying to say. Yeah.
Yes, Prof. Yes.
So you have to keep monitor this value, guys. Basically, you have to keep monitor these values. These values will contribute. Okay, these values will contribute to your Postgres database corruption. You can't do anything. No support people also can do anything in this case. What is the problem? It happens in the background.
But
Let,
Prof,
go
so
ahead.
if you like you are doing a lot of transaction that are creating a lot of transaction ID, and then you
Mm.
set up your vacuum to run on a daily basis, can it still lead to an issue like a transaction wraparound? Can
No,
it
no,
still,
no, no. That's what. If you do example, if I'm going to the database or cloud database example, if I'm
Mhm.
doing the vacuum, it will be come back to the original value. Vacuum.
Okay, thank you.
Yeah, just you need to do the vacuum at least on the database. It's a mandatory. If I run the vacuum, sorry,
Double C.
that's it. So if I run this, basically what happens? Let's see. The value will come down. There is one more command. If you see the very bigger value, there is a vacuum freeze. We use a freeze, so it will absolutely bring it to the lowest possible IDs. Active transactions only, active rows transaction only. It will keep the entries. All dead tuples will be gone, and they can be reused. I mean, the count will come down straight away. What is
But
wrong? This
I had a scenario where my friend had this transaction wrap around, nothing could work. Even restart, you cannot restart the server, you can't vacuum freeze, there was nothing.
yeah,
Only the
once it
support
is
was coming.
before it reached, you have to take the action. Once it is reached, it's a nightmare for anyone.
It was 2 days, 2 days downtime. It was terrible.
Even more.
We
We
had
can't do
we
anything,
had 2 days in the environment, 2 days downtime was terrible.
right? You see this value 111, actually, it is a very limited values got reduced. Okay, basically, you have to keep doing the vacuum. If you're doing the vacuum, it will be absolutely under control. Anyway, auto vacuum will take place in the production. We definitely enable the auto vacuum. It is mandatory to control the fragmentation of data. We know that data will fragment. We can't do anything because of the MVCC, multi-version concurrency control. We have seen in detail how it works, how it fragments the data. When the data fragmentation happens and your dead tuples will remain in the background, you have to do continuous maintenance. You can't do manually every time. So auto maintenance will take place in the real time. We don't have to do the manual maintenance at all on the tables because of the auto vacuum will take care. Mostly if you are seeing the very busy system and your auto vacuum is still not doing the job because of the operations are going very high, it is doing the little by little repair, right? Not too much. So in that case, you have to do the manual vacuum also, vacuum full also to reclaim the space. Vacuum only will remove the space, right? So if I go and check this one, it will get the unused space is released. You can see that, right? This can be reusable kind of thing. So this is what you need to know about. Let me write some notes about transaction wraparound. Let me, one of the output I'll take here. Here, transaction wraparound mean
Ravinder, can you simulate the scenario so that you
you
can
can't.
understand better?
You can't. That many we can't. 4.2 billion. We can't generate the transaction IDs here. 4.5 4 billion times you have to run a separate transaction to get that ID. We can't simulate.
Okay.
Here, transaction wraparound mean at database level. At database level, we have if we have performed up to 4 billion transactions, but there was no vacuum, okay, vacuum or vacuum full or vacuum freeze. We have to do this also. Vacuum freeze in a, if you see very big value, straight away vacuum freeze. Then we will see, okay, fatal error saying transaction wraparound exceeded. If you see this error, you're almost gone. Transaction wraparound error. Transaction
So there's a
wraparound.
limit of 4 billion transaction. Before that, we have to run vacuum.
Yes, for a database level that too. Any database can corrupt the entire server will not start straight away. It won't start. You have to come from the backups to build everything. You can't do
Okay.
anything. One database can cross the rest of the database also. That's the very bad scenario. We have to be careful on the transaction IDs of a database. Okay. And table level, you can grow up to 2 billion. One table can grow up to maximum of 2 billion, not more than that. The table level limitation that I'll write down anyway. If you see this particular table is having only 0 as of now. Why it is 0? The transaction age, because we just vacuumed it, right? Entire database. That's why the values are like that. So let me load some data to show you this at table level. We are loading from here. Yeah, here. So some inserts quickly. So just try to follow it. Table level, it should be 2 billion only, not more than that. It's individual transaction, not as a batch. Okay, one transaction, individual event. It can be loop. Entire loop will have only one ID. Not every thing that it is doing inside the loop will generate the ID. Now you go and check the table here. You see that total 6 times you inserted. Okay, 6 times you inserted. 6 times the counter got increased. Now it will be 7 times. So table level it should be how much it should be? 2 billion
Billion.
max at any given point. One table can go up to 2 billion. So that is a worst. You don't, it will never go. But as a kind of concept, you must have an idea. That's why I'm discussing this concept. This is a below query. Will list out table level transaction, active transaction IDs, active transaction IDs. Here is output. Here note. at a table, at one table level, or at a table level, I can say that one. At table level, maximum allowed allowed transaction IDs are 2 billion. Okay. If it exceeds, you can't do. If it exceeds, what happens? If it exceeds, database will not go down if all other are contributing up to 4 billion. Only one table is having 2 billion, rest are all only few millions. It won't create the issue. Okay. It will create the issue when altogether a database all becomes 4 billion. In fact, if one table become 2 billion, the rest did not contributing to 4 billion, this table entries will be blocked. If it reaches maximum value, then what happens? It will not accept any write operations, throwing the error. Transaction wraparound reached.
Here table will not corrupt, or we can
No, table will not corrupt. Only database can corrupt. When database reached 4 billion, that's where the scenario. Table will
okay.
not
If it
corrupt.
is reached at DB level 4 billion, what about other DBs and server? What is the
That's why
work
server
like
will
that?
not start because of one database. Rest of the database also you can't do anything. You can't start the server at all.
Okay, one DB is will be corrupt. Other DBs will after we reclaim the this cloud DB, it
You can't
reach 4
claim.
billion. Right?
Once
Uh,
once it is reached, you can't claim. It's gone.
entire server or only single DB will work.
Entire server will not start. That's the big deal here. If one database is exceeding the value of 4 billion, that's enough. Database entire
Okay,
server will not start.
okay. We need to restore all DBs.
Yes, come up,
Okay.
build from the your backup strategy. That's why I'm saying this is a one
Build the
of the
server
nice.
or only DBs.
No, entire server because all gone down, right?
Okay, if one single DB reaches 4 billion means entire server will be gone.
Yes, that's why this has to be monitored
We
anyway.
need to rebuild the entire server.
Entire server, yeah. Because you can't do anything. You can't start the server first of all. It will why it actually what happens in the background. Let me explain that part very quickly. What happens in the background is
Ravinder, here I got confused. Server in a sense like OS server, not right? Like only database.
database, not OS. OS doesn't have
Yeah,
the right. It's a product.
yeah.
We are server in the sense that our post is clustered for us. We don't
Okay,
refer the
okay,
physical server. As a database
okay.
guy, we only our server means our product server.
Got it.
Okay. So here, guys, if you see the transaction wraparound 1559 example, 1600 is a maximum case, assume a case you have 1600 already claimed. New transaction also will claim the what happens? Let me tell you diagrammatically here. Example, I have started with transaction ID 1. It went up to 4 billion. So once it reaches 4 billion, what happens? It will start from again 1, again 2, again 3. Okay, when it happens that way, you have the two IDs matching, old and new. Which one to be considered as a valid data by the system? It confuse. System will confuse. It doesn't know. There are two IDs. Which one to pick? It's a data inconsistency. I can't run the server with the inconsistency. That's the rule of the RDBMS system. So you are having two IDs within the table somewhere. It is renewed the ID because it reached the maximum value. It will start from the beginning again. So you have the two entries for the same transaction. That's where the problem comes. Inconsistent server. That's where the problem. That's why it will not come online because RDBS rule data should be consistent. You made inconsistent because of your IDs. That broke the rule, entire rule, the ACID rule concept. That's why it will not come online. Is that clear? Yes, no? Quickly say something. I have to talk about
Yes.
one more thing.
Yes.
PG, this one is something, you know, I didn't discuss in any of the batch, but let's, as Dolly raised this point, let's cover this up and move on. Whenever we do vacuum full, it's offline operation, completely offline operation. When you do the reindexing, you have concurrently option. Rebuild index, recreating index is a concurrent operation, in fact. Okay, clustered is not a online operation, it's a purely offline operation. So if you do the repack, it also equal to all these operations. In fact, we can do online, absolutely online, without a downtime. This is not a default plugin, it is developed by some third party. You have to install that extension, then go for the this kind of operation. For that, I am going to take a brand new server. I'll explain you from the scratch. This is something very vague, configuration wise. It's not straightforward. In fact, up to 13, it is straight. We have done the POC on 13. Okay, for the PG repack. So basically, that was used to have a straightforward package. Now things are not same. So we have to deploy a lot many dependent package to get that third party plugin. So I'll use the new server where we don't have anything as of now. I just build a fresh VM. So to do that simulation, we must install a lot of repos and dependent packages here. I'll close this. Okay, let's go through this. It's taking time. Right. So now what I'm going to do, there are a lot of like packages we need to install. First, enable the repos at the OS level. This can be done when you have a registered VM. I have given to all of you enterprise registered VM. You all can do what I'm doing in the class. This is something enterprise server with a registered there is a subscription I have. I registered that VM with my subscription. I gave you the object. So by default, you'll get the registered server, in fact. So I'm going to do first enable this, get all the repos for my configuration. It is going to verify my subscription, enable all the RPMs, whatever I want to download and install, it will enable it. Third party extensions, everything. Let's do this. Is a slow operation. I just want to give a knowledge on this. Basically, I did not cover this in the previous batches. But anyway, let's go through it, how it works. It is simple and straightforward, very simple once the installation is done. But for installation, lot of headache. It's not a easy plugin to get it. Okay. So it takes some time. Do we have internet on this first? If not, it won't do the job. It's very slow. So on the transaction wraparound, you all clear, right? Simple and straightforward. Active transaction IDs are growing up to 4 billion on a database. That's something I never seen in my career. But anyway, if you are not maintaining the indexes time to time, using the vacuum or vacuum full or freeze, yes, that can happen. So ping Google. It's not going through. In that case, NMTOI. I'll activate our secondary Ethernet card. This we have discussed many in the previous classes itself. So I'll ping the Google now. I can ping. I'm reaching the internet from the VM. Okay, the NAT gateway that Ethernet was down. I made it online. Now it is talking. Now let's see this. I'll cancel this. I'll do the same thing again. First, I'll enable this. It will verify your subscription before it enables. We had to wait for that too. Was it done? What happened? It's taking this long. It takes some time to verify my identity first. It's taking that long. Right, it is done. Good. So once this is done, I'm going to enable the repo. This is the I'm going to clean the all if anything is there in the buffer as part of the OS, what it is calling for the Postgres. I don't want to have it. Just clean that up. I mean, any OS integrated Postgres modules kind of. Right, it is removed. Remove the cache as well. This is a long process, guys. The installation itself it will take all these dependent packages roughly 40 minutes plus for sure. We can't do anything. If you have to explore, you have to run through all these methods. If you can't do this, it won't install. I verified personally. It is not working. So I have to install all these packages. It's a very rare that people do implement this, but anyway. All right, this package is done. Then get the repo and getting the Postgres repo to install Postgres direct Postgres binaries, development packages. It used to be very straightforward in Postgres 13. In the higher version 15, 16, it is not as straightforward. I tested it thoroughly on this one. Okay. So you have to definitely install all of this. Why you have to install also I have written there is a notes mentioned in this. Come on, these are all default ones. In fact, I should have disabled. Cannot install the best. The package, but none of the okay, just a minute. This could be the cause of this, where we need to disable this, huh? Where we've used that. Not here in the source code or GUI based installation. This one should be the cause of the problem, I feel. It will run through many issues, I feel. It's not straightforward. If it is not happening, I use this machine itself, I enabled. I'll show how it works. Let's give it a try because I tested it this one already. Where on this time. Right. Because of that, it was interrupted, the default one. That's why we have to disable it all the time. Let me mention that as well. Why to miss? Before you run this one, disable this. We must disable default OS Postgres packages. Do not to interrupt our installation. It will come with the default Postgres, in fact, old versions. So configuration is lengthy, but discussion will be straightforward. What is advantage? I'll explain. I did not include this in our course anyway, okay, this concept, but still, uh, as Dali raised this point, so I want to cover it up. Anyway, I'll include this going forward. You follow the steps what I've given, okay, it is direct solution. There are a lot of issues when I was verifying on this. I made straightforward notes because that up to 13 it was straightforward. With one plugin you run, it will install and integrate. But 15 onwards, it's not straightforward. It become too complex, right? This is done. We are good in shape then. So then we have to install this. Keep them in the same sequence. If you break the sequence, dependencies will be, missed. I've tested many times to know the sequence because there is no good help on that in the community also. Right. Good. It's a good to have feature, in fact, but not all people implement. We did not implement this. We did the POC in 13, but after that we left it. It has advantage. People can implement it. So what are the advantage you understand once we discuss about it? Basically, it has some prerequisites also to do the job. You must have a unique key or primary key on the table. If not, it won't do the job. If it is heap table, it will skip straight forward. If you do at database level, schema level, table level, it will definitely verify that. You must have a unique key or primary key. This is a compiler, GCC. This will compile your code. It's very important. This for any installations. If you do with the source code, any product, these are common. GCC and make. It's there, so no issues. So then last this one. Right. I need to install the product also on this quickly. Okay, let's do the repo-based installation quickly because this won't take too long. This one itself. So we already have this repo I ran, and then I'm going to install the product straightforward. I don't have Postgres server on this. It's a new machine. This got installed. Open SSL. Okay, we are done with the these things. Let's go to install the product quickly. So I'm installing Postgres 16.5. We don't have Postgres. This is a repo installation. It does everything for us. We discussed about this already, right? This is install the product. Now you want to keep your product in the PG cluster, var PG cluster. So not in the default var lib directory. By default, it go to var lib. So I want to build my own directory here called PG cluster, and that I need to take the ownership. So I'm straightforward, doing all this. We discussed every step in detail. So I'm just running one by one. We want to initialize the product now. We took the ownership. I'm going to initialize the product in that directory. Initialization is done. Then as we install the product in a different directory, we must run this one to use the system CTL. PG cluster. Okay, it works. Then I'll start the product. Enable, it's not required. At least I'll start the product. So let's see the status. Right, it's running. Now if I use a PSQL, okay, PSQL, I have to go to Postgres, SU Postgres, PSQL. We are in the server. We will have a default databases. I'll create one database. Create database lab example. I need to enable the extension PG repack to use that. So it won't come directly. Create extension. We installed, but we had to integrate with the product also. PG repack. Right. What it is saying, you can see that extension is not available. Okay, you can't enable the extension by default. So we have installed all dependencies here. Now I have to get the actual product. So this is where we are going to get it. In fact, if I go to this website, you will find it. If I go up to this thing, it's a third-party site. In fact, they developed this product. Not found. I could not find. What? Right, you can see that all versions, in fact. Okay. This used to be this one 1.3.2 was the 13 Postgres 13. Now you are on the 1.5.2. You have to go to the highest version. If you go with the lower versions, it will show incompatible issues, in fact. Okay. So if I click on this, copy the link, this one, and then you can do the double get to get this. So I need
So
to,
it doesn't go with the Postgres version.
sorry.
Does it the PG repack version? It has to match with the Postgres version, correct?
Yeah, actually, yes, but this is the latest one which you need to go with up to 15. 15 onwards, you have to use latest one. Yes, 14 might be integrated with the 1.4, I feel, but 16 1.5 is mandatory. 13 will be 1.3 combination, 1.3, 1.4. You can see 1.5. 1.5 is the latest one, which you can integrate with the 17 also. That right now, this version is mandatory. The older version won't integrate. Repack won't work. Incompatible. It will throw some errors. So anyway, I'm going to download the one which is valid. Okay. So we need to where I want to keep this PG data. What do we have in PG data? Okay. Some more things we have to do, right? This one, we need to get the binaries to be accessed quickly. For us, user PG bin, and this one will be PG cluster. Just a minute. I have to do this as well as the next step to access the binaries. If I run the PSQL here, this will access anyway. It is accessing. You have seen that. So let's go out. And which PSQL, where it is reading from? User bin PSQ. You can see that it's reading from here. It should not read from there. CD user. Those are all OS built in. I don't want that. This is one what we have installed now. These are binaries. So to use this, those are all Postgres inbuilt. This one is correct only. This one is PG bin path. Bin path is this. PG data must be this. So this is a bin directory, guys, where we want to access the binaries, where we want to have our data directory. So this we are loading under Postgres user profile. This tilde is a tilde symbol will take us to Postgres home directory. Under that, it will load into this file bash rc. So I'm going to export this. Maybe you have to recall these discussions, what we have done in the beginning. Now, which PSQL? It should read from here, not from here, where previously where it was reading from. Here, right? This is the OS built in Postgres. This should not be used. Okay, we should use our latest version, this one. So to use that, you have to export it. Right, this is one thing. Next thing is I want to get that, right? CD, let's keep it here only. PGSQL 16. Here I want to download this thing. If you're confused, let me know. I did not do anything. I just installed all dependencies, install the product because we need to test with the product, right? So I'm going to download this.
Ravindra, did you upload this dependencies list in this Google Drive?
This dependencies, yes, I'm going to do after today's class.
Okay, okay,
Right.
okay.
So I'm going to get that software. It is there. Unzip. It is in the zip format. You can see that unzip. And then first it got unzipped. You can see that. Under that, you have the actual command, make command. Here you need to run the command. What is one that command you need to run is this. So pg install, make install pgconfig user bin. Yeah, it is correct. So what we need to do here is, you downloaded the package repack, extracted it inside the repack. Here you should be inside this package location when you're running this command. If not, it won't run. See, you are inside the package when you're running it. So the command is absolutely correct. User pgsql16 bin, yes. So where it is going to build its binaries under this location, under bin location. It is going to build pgconfig. It is going to use pgconfig. It will build our pg repack binary. So let's go and check. Before I do this, let's go back and verify that binary doesn't exist. Cd bin. If you go to see that pg repack, you don't find pg or somewhere. It comes here. You don't find pg like repack here. So once I run that command, it will build that. It will build automatically that. Going back again, because I need to run from that location only. Pg repack. Then I have to run this command. Then it will enable that binary. For that binary only we had struggled all this, in fact. So now it is building that binary. Done. Now I'll go back. I'll go into bin directory. It was not there before. It will be there now. Cd bin pg repack. You get this one. To get this binary, we did all of this actually work. In fact, installing all the packages. If you miss anything here, you can't install that package. I have verified it. Many combinations I verified it. First I installed this and the rest, then it was not installing it. To have this in the order, it took me almost a lot of time. Okay, a lot of time I spent, because there was no solution given anywhere. I had to explore everything, on my own. So the steps are very much important in the sequence. Okay, else you will see some issues. Now this is how, when it runs, it builds the log, because I kept it everything to have an idea how it runs kind of. Then as we have this location accessible directly, so I can run the pg repack, okay, version. It is running fine. So now I'll go to the database. Now run the extension PSQL use lab, right? What I created. Now I create the extension. It will create, because we have that binary. Create extension pg repack. If I run this, it will install. It was not doing before. Now it did, because we have installed that binary pg repack. It is there. It is supporting the action now. Now let's come to the actual discussion. Absolutely actual discussion. We don't have any table. I'm going to create two tables for understanding sake. Two are enough. Create table student s number integer primary key, one with the primary key, one without primary key. To understand this, how it works. S number varchar 100. Right. Second, oh, what happened? Column s number specified more than once. We did once. Oh, shit. This should be s name. Fine. Next, I'm going to create one more table called teacher without primary. It is intentional to show that it won't work on the table which, if you don't have the primary key or unique key, at least you must have. Why it is, I'll explain why it need that. So what does this will do? Let me explain the functionality of it first. It is a purely vacuum full also online. You don't have to do the vacuum fill anymore if you're using this PG repack. It does everything. In fact, vacuum fill does the, what are the things vacuum fill do? It does the analyze, it does the vacuum, and it does the reindexing also. Vacuum fill equivalent to every operation. See a similar operation the repack will do. So understand here. Example, I have a database. I have 4 or 5 tables. Just assume a case. It's very important. You have the disk here. One of the table is 100 GB. Assume a case, and plus 5 GB indexes. Okay, and the rest is 10 GB, 5 GB, 20 GB, 50 GB. Doesn't matter. When you run the PG repack, what does this will do? It will take the entire table into the your another copy of the table into your disk, in fact. So if I have 100 GB plus, right? If example, you must have minimum 105 GB free space to run that, because it is taking your indexes and data into another copy, the largest one you need to look at, because it does in the order 1 by 2, like in the order 1 by 1. It will not do in parallel. When you do the database level PG repack, it goes to the every table. It need maximum highest table size as a free space. If not, it is not going to work. It will throw the error. It should to take the copy of the entire table into your disk as another copy to do the online operation. When table is accessible, it takes the entire copy. Once entire copy is built, it will replace here. When it is replacing, it is a downtime, brief downtime, not big downtime, brief. You will see that connections are blocked entirely when it is swapping the actual base table. Once it is really done the vacuuming, analyzation, indexing, everything will be done. It is reload, entire data got reloaded. It is equivalent to vacuum full. Absolutely. So you have to verify that the largest table in the database, and you have that equivalent free space. If you exactly don't keep it tied to value, 100 GB plus 105 GB, at least keep 120 GB free space. Then only run the repack, else you'll run into issues. Vacuum full will not create any issue because it is does the in place. It is a purely downtime activity. It doesn't need a new copy of the table. It is working on the base table itself. But PG repack is online. When it is online, it need a free space. At least keep 5% of the free space more than your largest table. At least that's a minimum to run the PG repack. Is it clear? Yes, no?
It doesn't impact any, on performance while doing this
Don't. Because
PC
your base
repack.
table is still accessible.
So like it's online completely now.
It's online. Yes, it's online because vacuum full does not give you the online. Okay, there is no
It's
inbuilt natively you
equivalent.
can get the online.
Hello, Ravinder. It's equivalent to vacuum full, right?
Absolutely, it is equivalent to vacuum full. It does everything for you. It is reloading entire your data, guys. It's reloading entire your table copy here. It is reloading all your data. Once everything is in place, it will swap it. When the swapping is happening, brief, you will see the blocking. A very brief, it will release the lock. It will continue automatically. Okay,
While
fine.
doing this operation, will get any performance issues like or it's normal.
There will be load, of course, only towards CPU memory side, but not the blocking side. If you have good memory and CPU, you don't feel that. If the CPU memory under pressure, you are doing this, it will add up more load. Yes, performance can be degraded during that time. It's taking the load already to do the job, right? You already server is hammered, you are still hammering, you'll see the further performance issues, yes, but not
Uh,
blocking.
Ravinder, if for example you taken a snapshot for doing this vacuum analyze and reindex when
Mm,
we're using the PG repack. So
mm.
if the table is, I mean, concurrent transactions are going on during
Right,
that.
that will sync, and come, and Everything is in sync with this. It's not just doing it. It is syncing all your operations as it is going on, as it is happening, and then it
So
replay.
Ravinder,
Okay.
as
Go
you mentioned, suppose you have 100 GB of data in all the tables, so it need
Not
another
all, one table. One table,
one table.
largest one. Largest one you need to consider. The smaller one you don't have to.
Okay, what about those tables then? It will
It will do in the serial, right? It will be gone, it will flushed, it will take this copy and you reuse the same space, of course.
okay.
The large one you have to consider for this free space, not entirely. One, it will do in the
So
serial.
so it will take the copy of that table in the another blocks in the
Yeah, another storage, like within the disk.
storage. Okay.
It
Okay.
means that one by one it will be complete. At a time, only one
Yes,
will be run.
yes, one by one, exactly. That's the
Okay.
functionality of PG repack. Now let's run. You can't run within the product this command. You have to run from the OS only, in fact. In the PSQL shell, you can't run that command. You have to run from here, in fact. So PG repack, okay, and username. We don't have, it is trusted already. I'll go to database, lab, and table. What is the table name? Student, example. If I try to do it,
You are running PG restore.
oh, the shit. It resolved automatically, it seems. Right. I had to go to Postgres to detect that command, su Postgres. So each command also I have written here how it can be done, all that. Okay. So PG repack, database name is lab, table is student. It done the repack. If I do the teacher table at the same time, it will throw the error. Here, must have a primary key, not null unique keys. So why it is needed? The problem here is when you're doing the operation, it has to sync. At the same time, it is reloading the. If it has a duplicate values, how many duplicates you have it? ID conflict will come because it's reloading again, right? So how many rows we have, it has to uniquely identify on one field. You might have duplicate one of the value you modified, other you did not modify it, but when it is copying, it can modify all because there is no unique key. So unique key is enforced. If I'm doing a table level, you must have the primary key. If I do a database level, I'm not calling the table, I'm doing just a database level, it will comfortably skip the tables which don't have the primary key or unique key. It will do the vacuum full automatically in all tables where you have a primary key. It won't complain. But if you're going with the schema, okay, if you are going with the schema public, so then it will complain. Then you need to call the schema first. Schema public. Yes, parameter public and database is lab. So this will complain. Table space. That's not, should be INI. Database public. The heck? How the schema just up? I need to know the switch. Database level, table level, and only indexes. Where is the schema level? We can do it schema level as well. Right, here is the schema. -c switch must be known. Okay, right. So you can see that repacking this is done, but relation teacher must have a primary key. So it is doing where you have a primary key. It is giving the warning where you don't have when you're going through the schema. It is that way. So you can do a database level, schema level, table level. These operations are allowed. If you want to only do the indexes, you have to mention the table name, only indexes. Only indexes only can be called when you call particular table, not for multiple. at this is a table level. This is only a table level. We can call table level indexes, only indexes when we do at table level, in fact. Okay, this is about repack, guys. Why we need to install, I have mentioned what are the dependencies of each what we are running. Okay, any questions on this? Straightforward, but installation is tough. It took almost entire day to figure it out, to what sequence to be followed. There were many errors, in fact, but this combination took a lot of time to make in the sequence. Anyway, fine. So let's go to the backup restore. So any questions on this? I'm going to close this as well. Let's go with the introduction of backup restore for today.
Actually, this repack will allow in organization, like as you said, this third party tool, right? So
It is allowed. It's allowed. It's open source only, but depends. Companies are implementing or not. Depends, because it has need a lot of dependent packages and all that. Depend. We are not using it. The company policy wise, it's not harmful anyway. But some people don't trust anything which comes out of the product. Not all people can be trustable, right? Right. So now backup restore. We have two types of backups in PostgreSQL. Okay, what are those? Logical backup. First is the logical backup. Next is a physical backup. Physical backup. Again, under logical backup, let's talk about one by one. Physical will talk in tomorrow topic. It takes 2 more classes to complete backup restore anyway. Logical backups. Under logical backups, we have again two types. In fact, okay, plain text backups. Let's go with the A. Plain text backups. B is custom backups. Custom encrypted backups. They encrypted, in fact. Encrypted backups. We always take the custom backups only for the company compliance, because here we can directly read the data from the backup. Plain text backups and custom encrypted backups. So let's talk about again this one first, one by one. Let's make it as headline because this is important. One by one. We have many types of backups in Postgres, so don't confuse. I'm going to give you in organized notes so that you can easily follow. So we have two types of backups, logical and physical. Under logical, we have again two types of backups, plain text backup, custom encrypted backups. So let's finish this part. I'll come back to this part. So plain text backup, we have pg dump is a command which we're going to take the backup, pg dump. So this command, limitations wise, this command will be used to take the database level backup, not server level. So limitations of, first let's know the limitations of pg dump command. So first, you can only take one database backup. We can only take one database backup at any given point using at one go. You can run one after the other. We can't take server level backup using pg dump. at one with one command. We can loop it. That's a different story we're going to talk about. Automation is a kind of topic. We will talk about that in detail. Okay. We can take database level, schema level, and table level backups using that. All that. Okay. So let's take a database level backup. Database level plain text backups. What we're talking about? Plain text backups. So let's go to here. We have many databases, so I want to use this because we have many. Let's use this itself, not an issue because it will be easy to verify as well. One database. Let's create one schema also. DD, we have two tables, right? Let me create some tables, and load some data, and then we'll play around. I'll just give only some introduction. Don't worry. Create table customer. Postgres backups are little, many types of backups are there. You have to be little focused on this, please. Customer name, worker, 100, whatever it is. So I'm going to go this. So create schema also. Let's create schema because we're going to play around schema also. Create schema name is testing, whatever it is. Create table testing dot class number integer, class name varchar. Let's create another table. What it is, testing. Schema name is also testing. What do we call? Practice, whatever it is. P number. Doesn't, how it works is matters here. P name. Okay, right. So now we have 3 tables under public schema and 2 tables under testing schema, right? So let's generate some data also into each one quickly. Customer, insert into customer values, generate this 1 to 100, comma. Oh, we have only 2 fields, right? That's enough.
Values.
Yeah. All right. Next, I want to show that data also we need to play around. So let's load some data. We are preparing this because I'm going to talk many scenarios, new database will create for that. So already we have too many databases here. It will become clumsy to understand because we have many, right? So let's create a fresh one, play around. The concept is same, bigger or smaller. Student 3, right? Insert into student values. Here also generate. So generate series will work where you have the number. There you can replace it. Okay, that will generate there. In the first position, I'm using it because it is a number. It is that way. 200. Right. Testing. What are the tables we have under testing? Class and practice. Insert into class values. class number again generate is 1 comma 10. Or testing.class, of course. You have to call the schema. Then class name, teacher. Uh, we just have class and class name, class and practice. Sorry, practice and let's use whatever sports kind of thing. Example. Right, we have this data. Now let's talk about few commands. Don't worry. So I want to take the database level backup. So here, let's go to cd where. Let's create one directory. Let's create pg data, wherever, doesn't matter. It own the directory, so mkdir backup. Here we're going to take the backups. cd, because it's own the directory. It should own the directory. If not, it will not write the backup. Now here I want to run the backups. So here I want to run the backups, in fact. So use the, what is it? Let's use pg dump. Here Postgres, I'm going to use it, but by default it will be there because we are using the Postgres. Database, what database we are dealing with? Lab. So where I want to take the backup? Where pg data and backup. Here lab full backup. Let's make it this way. .sql. It's a plain backup, so it should be SQL. So it generated the backup here. It is a full database backup. Now I want to take the schema backup here. Next schema, which means that one schema backup here. Schema backup, what we have testing schema. Here lab underscore testing underscore schema. So one schema backup, entire database backup, and then we're going to take tables backup, whatever the tables I wanted to. So I have to mention the table name. So here customer, student, teacher. So customer, student backups I want to take, or else one customer from the public schema, one other from the testing schema. It is possible. Anything you can call. You just need to call one table or multiple tables. It depends. So I want to take customer backup and practice backup under here. So T customer, when it is public schema, you don't have to call table testing dot practice. So we are taking the table level backups. So I'll mention that clearly. Table dot SQL. It took the backup. Now I want to take only schema backup. I don't want anything. Okay, just a schema of all tables. Schema only. This will take only schema of all entire database. DB schema, I'll call it as. I'll write the notes. First understand, I'll explain schema. Yeah, DB schema. Schema only backup. Oh, I mentioned the customer here. No. We're taking the schema only backup. Now data only backup. I mean entire schema, entire data of the database. Okay. Now you go and check. We generated all these backups. So quickly, we'll restore them as well. I'll keep it all backups. PG dump, plain text backups. Text backups. Yeah, this is a database level backup. This is a schema.
Sir, data and schema in a sense, schema in the all tables.
No, schema one, we have a schema right in the Postgres, like
Yeah.
we have DN if you go to, right? We have testing schema and public schema, right?
Yeah.
So that schema I'm saying here, schema backup, which means not the actual structure. It is one of the schema level backup. And here tables backup, tables backups. And why this has come here? This is a purely structure database, all objects structures backup. Structures in the sense schema, not to confuse. Okay.
Only structure,
Only
not
structure,
data.
not data. Here, all tables data, all objects data backup. Okay, let's restore all of this. What is the compliance problem with the plain text backup? I can read the data from each one. So you can see this table has this data, this table has this data, this table has the entirely you can read. It's a definitely compliance issue. It is not encrypted. But anyway, we need to know it, how to take it. Custom backups I'll cover tomorrow. Let's restore all of this quickly. So to see that, so I'm in the Postgres. If I want to restore as a different database to show you that, okay, I need to show it, right, how it works. We have these databases, timing on, right, timing off. These databases we have as of now. Lab, all default. I wanted to restore this entire database as a A1 database, A2 database to show it. To restore the database, we have to use PSQL only. When you take the plain text backups, to restore, we have to use PSQL only. If you're taking the custom backup, PG restore, separate binary. So I wanted to restore this as username, Postgres. We did not enable the authentication. It is a trust for all. So that's why it is not asking for the password. We know that PGHB, how it works in detail. Now, as what database I want to restore? I want to restore it as A1. From where? From where PG data and DB full backup, right? What we have used, full PG data backup again, right? PG underscore full. That's why it's not resolved. Lab.full. Okay. All right. If I restore, it'll throw the error. If you want to restore as a different database, you have to create empty database. It's a mandatory in Postgres. So it is throwing the error that A1 does not exist. Let's come to here, restore plain text backups. We have to use PSQL only to restore. PSQL binary only to restore plain text backup. If custom, you have to go with the PG plain text backups. This is very important note. Right. So to create restore as any database, you must create empty database. It's a mandatory in Postgres. So create database A1. If I want to restore it as A1, I created. Now I'm going to restore. It is restored. Okay. So I'm going to give it this only this command, not the output. Okay. So before that, I'll give this also. In Postgres, if we want to restore a new database, we must create empty database before restore, before we restore with that name. It's very important. Schema also you have to create. If you are restoring one schema, empty schema you have to create. It won't create. That's how Postgres is. So now it got restored, right? This one. So if I verify the database here quickly, so A1 we just restored, right? A1 here, DT all tables, and DN all schemas. So if I read the data, count asterisk from, you should get the data as well, of course. Customer, you got the data. If I read select asterisk from count, let's give it count from testing.practice, right? What we just restored. You got the data. Everywhere you got the data because we just restored, right? So this is a verification. Do you want? I don't have to keep the verification. I'll just restore. I'll keep this thing. Database level restore. Database level restore, because it makes very huge notes, because we have to talk a lot many scenarios in this module. It makes very big notes. You might feel confused. Database level restore. Now I want to restore schema level. Schema level restore. This one. We took only public schema, right? So if I want to restore that, first I want to create a new database again to show you that.
Ravindra, if you add that, will be easy to understand after restore.
Entire thing? I can.
First, yeah.
It's okay. I can keep it. Not an issue if you want, because okay, let's give it here. Okay, verification. It's okay. I mean, if you want, because this is going to become very, very big. So then schema level restore. To restore the schema level, I'll create one more database, and let's do that. Create database A2 and do that restore. 2 minutes, guys. We are done. Quickly. These concepts are there in every type of backup. That's why I want to cover it today. Else, schema level is this, right? So I'll use the same command, but db underscore testing schema. That one, the testing schema, right? Why it's not calling this?
Lab underscore testing.
Okay, right. So here I should give the A2, only A2, quickly. Right, now you go to A2, then you get those tables only. You don't get here, but you do get under testing schema, 2 tables, including the data. Select asterisk from testing that practice, you get the data, and also you have class, you get the data, because it was specific schema backup, specific schema data got generated. This is a schema.
Ravindra, database level schema automatically created, no need to create manually, right? Before restore.
Right, at database level, if you're doing it, a schema will create automatically. But if you are doing it schema level, only schema level, then you need to create empty schema. That I'll cover tomorrow. Well, we are over time already. Restoring the schema backup. Schema means data within the schema. Okay, schema backup.
Before
Here,
restoring schema, you created schema, right, in A2?
no, it is database level, right? I came from database. If I call particular schema, then I have to restore schema backup. Here we have restored schema backup, schema data, particular schema data. least that way. Okay. There are many scenarios, guys, in the backup ratio. As we go on, we'll build it. Let's not finish it in a hurry. I'll start where we will talk about one schema backup, one tables restore, and data only restore, schema only restore, everything in the next class. Okay. We are over time already. It will delay more. I'm stopping it for now.